everyone, by names of Dushmerene, and today I'm going to be presenting you electron transport system and oxidative phosphorylation. Enjoy. Hello everyone, now we are going to start talking about the electron transport chain. So first of all, we must get to know the mitochondria. So this is the outer mitochondria membrane, and this is the inner mitochondrial space. This is the matrix, and this is the inner mitochondrial membrane. So the electron transport chain occurs in mitochondria, and we have four complex which are involved, which is complex 1, 2, 3, and 4. So I'm just going to give a simple summary on how it's going to be. So in the first complex, first of all, this is the outermost membrane, this is the innermost membrane, innermost space, this is the innermost membrane. So in the first complex we have NADH hydrogenase complex, and this one is a complex. As you see, it's a hydrogenase, so that means that it will remove hydrogen from NADH and giving the electron to the complex number 2. So complex number 2 is called succinate dehydrogenase complex. So if it is succinate, as you know, this one removes hydrogen from succinate and converts it to fumarate, and this one, you know, it's a step from Krebs cycle. And so after converting to fumarate, it will transport the electron to the complex number 3, which is called cytochrome reductase. So this cytochrome contains 3 cytochromes. This is cytochrome 1, cytochrome B, and cytochrome C. So the electrons which are transferred to cytochrome reductase, which is complex number 3, they will be in cytochrome 1 and cytochrome B, which will convert it to cytochrome C. So our electron will be converted to cytochrome C. So as we go to the fourth step, which is cytochrome oxidase, so that means that we are going to get our cytochrome, which was cytochrome C, and we shall reduce water oxygen to produce water. And here the last step, where we shall bring ATP synthase, which we are going to produce our ATP. So that means that all about this, it is all about formation of energy. And here, because this electron transport system, it's all about provision of energy. So this energy will be used to produce a lot of hydrogen ions, which will flow to a high concentration. So more concentration will be hydrogen ions here, and here there will be negative ions. So this will make it a positive inside and a negative outside. So let me continue to show you now all the steps on how we are going to get our ATP and also the calculations. So as we continue, this is our outermost membrane, innermost space. This is the innermost membrane, and this is our matrix. So we are going to continue on how we are going to produce ATP in a brief way. So we shall have our NADH, which and FADH2, which are brought from the Krebs cycle. If you saw my last video on Krebs cycle, so this NAD is going to enter in the first complex. So this first complex, it's L-shaped, that's why you can see it looks like this. So this will be from FMN to the sulfur protein. So this sulfur protein also sends it to another FAS. So this FAS is going to send this to COQ. So here there will be production of 4 hydrogens in the matrix, which the energy which is going to be produced will get this 4 hydrogen from the matrix and pumps it in the innermost space. So we shall have 4 hydrogens in our innermost space. So going on our second complex, so here it's a stage of Krebs cycle. So we shall have our FADH2, which will be also going with the sulfur proteins FES, and this also will send it to COQ. So this Q will combine with our hydrogen to produce QH2. And going to our third step, our third complex. So this third complex, it's where we have our cytochrome. So this one is going to pump the electron to cytochrome C. So, and we shall have our electrons from cytochrome 1 going for the sulfur protein and going back to cytochrome B, and this cytochrome B will convert it to cytochrome C, as you saw my last video. So this cytochrome C will go in our last step, which is step number 4. So this cytochrome C will be converted with copper. Copper sends it to cytochrome A. Cytochrome A again to copper and to cytochrome A2. So, and in this process we shall have oxygen combining with hydrogen to form water. And the last step is ATP synthesis. So every hydrogen which will be produced will pass through ATP synthesis through the higher concentration to low concentration, making ADH to be turned to our ATP. So we are going to look on how we are going to calculate our ATP, which is produced from our Krebs cycle. As you see here, 1 ADH gives 10 hydrogens. This is 10 hydrogens. So, and here, as you see, 4 hydrogens, when they go for ATP synthesis, they produce 1 ATP. So here, if one NADH produce 10 hydrogen, so we shall have our 2.5 ATP produced per 1 NADH. So 1 FADH2 produce 6 hydrogen, so that means that we shall have 1.5 ATP produced. So going back to our Krebs cycle gave 2 NADH, which we gave 5 ATP. It gave also 2 NAD, which will have 5 ATP. Here we have 6 NADH, which will give 15 ATP. 2 FADH, which will give 3 ATP. So the total will be 28 ATP produced. Thank you for watching my video.